All right, so once again, yesterday we started with relations and functions, but we did mostly relations. And our objective that we started with was I can identify and define and graph relations and functions. And I said relations and functions fall under the two variable equations concept, right? That's why we didn't do a Freyer model. So from there, we went ahead and got some steps down. And yesterday for homework, we represented ordered pairs using what? Tables, mapping diagram, and graph. You guys practice that? Yeah, right? From there, on some other problems, you did step 2. You identified the domain and range. But yesterday was only focused on relations. Today, we're going to finish the second part, which is on functions, and we're going to define relations or functions. Okay? And then yesterday I gave you guys some vocabulary. I said relations are a collection of ordered pairs. I gave you guys definition for function, and I said it's a relation that assigns exactly one output value for each input value. We're going to cover that today. We know what the domain is. The domain is all x values, and the range is all y values. Okay? So yesterday, for relations, I said I'm going to do a quick introduction using a vending machine. And I brought out the soda machine from Q-Fresh at 23 cents each. We created a table and so on and so forth. Remember that? And I said each of those relations becomes a ordered pair. And since it's a collection of ordered pairs, that's why it's a relation. I gave you guys an example. I gave you guys a solution set such as this one. I'm sorry, a relation, and we went and represented 3 different ways: using a table, using a graph, and using a mapping diagram. Are we there? Okay. From there, you did this one. Did we finish that one off? Yes. So therefore, I gave you guys this relation, and then you should have represented that 3 different ways: using a table, and it looks something like this; using a graph, it looks something like this; and using a mapping diagram, which looks something like this. The domain, we said, is all x values. So if we look at our table, what are my x values? 1, 2, and 3. So my domain is what? 1, 2, 3. My range is all y values. So therefore, my range is 3, 4, 5. So far, so good? Okay? So with that said, copy this one down, please. Example 3. And it says, give the domain and range of the relation, and copy this grid like this, and this graph that's inside of that grid. Okay, so on your homework, there was one problem that I left you, such as this one, and I just wanted to see what you saw. But here it goes. I'm going to go ahead and break this down so that you understand as to how to get the domain and range of a graph. So here we go. Pens down, eyes up here. So before I move forward, when we got to compound inequalities, and who's noticed that I still give you compound inequalities in the warm-up, right? Watch, and let me show you why. If I was to give you a compound inequality such as, and I gave you a graph, let's see, 0, 23, and negative 23. And it included 23 and everything to the right. I'm sorry, negative 23 and everything to the right. And it included 23 and everything to the left. We know that this is an AND. Is that correct? All right. And to get the solution set, focus on this one or you're going to miss it, please. To get the solution set for this one, we write negative 23 and 23. Which variable do we use? Did they give us one? No, I'll just use the variable Q. Okay? So, what is negative 23 compared to 0? Less than. Does it include negative 23? Yes. Okay. What is all these numbers, which include 0? What is 0 compared to 23? Less than. Very good. 0 is less than 23. Does it include 23? Yes. So my solution set for this compound is negative 23 less than or equal to Q less than or equal to 23. Are we there? However, who notices that we only have one number line? Because we're only in what? One variable equations and inequalities. Are we there? But now that we are in two variables, now do you notice that we no longer have one number line? We have how many? Two of them. We have an X value and a Y value. That's why, everybody look up please, that's why this red is not just right here. Does everybody understand that? Now it's slanted up because now it includes not only values of X, it includes values of Y. Are we there? So now check this out. So if I was to ask you, check this out, if this was laid out like this, right here, what would be my solution set? Think about it. Don't say it out loud. What would be my solution set on the X? Think about it. Okay. Tell your neighbor, what would be our solution set for my X here? Go. All right, here it goes. If I was to bring this down to this line, it starts where? At 1, and it ends at 5. So my solution set would be 1, 5. What variable are we using? X. Therefore, what is 1 compared to all these numbers in the middle? Less than. Does it include 1? Yes. What are all these numbers compared to 5? Less than. Does it include 5? Yes. So therefore, my domain is from -1 to 5. Copy that, please. +1 to 5. Sorry, +1 to 5. All right, so we got the domain, and the domain is from 1 to 5. And if we were to read this, it says all real numbers greater than or equal to what? 1, but less than or equal to 5. Are we there so far? All right. But now they're asking us for the range. For the range. We got the domain. Now we need the range. Now check this out. The range, we said, is all Y values. Now, pens down, eyes up here. I'm going to do something so that you can see how do we get the range. Here we go. All right, check this out. I'm going to turn this so that the Y is going to be the same direction as the X. Check this out. Does everybody see it? See how this is a real number line, but it's the value. Which variable are they using? Y. So now check this out. So if I was to find the range, okay, let's see. What is my solution set? Don't say it out loud. Think about it. What is my solution set if I was to place this on this line? Okay, tell your neighbor, discuss it with your neighbor. What is the solution set? All right, so let's see. Who saw that if I was to place, guys, if I was to place this and bring it over here, we are at 3. And this one, we place it over here, and we are at what number? 4. So my range is from 3 to 4. Are we there? And what variable are we using? Y. Okay, so now check this out. So 3 compared to all these numbers in between, what is it? Less than. Does it include 3? Yes. And let's look at all these numbers compared to 4. What are they? Less than. Does it include 4? Yes. And that's how we get the range. Now check this out. I did this so you can see it. Now let me show you how to get the range without twisting the graph like that. Because I just wanted you guys to understand that this is a separate number line. The first number line was what? X. Now this number line is what? Y. So now check this out. Pay attention, please. Here it goes. So let me go back to my, oh, sorry. So let me go back to my graph, and let me go back to the previous one right here. So now check this out. This is how easy it is to find the range. Pay attention, please. If I was to ask you to get your pencil, okay, and I said, you're going to get your pencil, and you're going to place it sideways, like this, from far away. Place it in front of your eyes. Do that right now. Get your pencil or your pen, put it in front of you like this, and I want you to scan. Yeah. I want you to scan like this, from the bottom up. Everybody look up. Where does it first touch that graph? At 3. Does everybody see that? It touches at 3. If I continue going up, where does it end? 4. So therefore, that's how we get our range, from 3 to 4, and it's the variable y, less than or equal to, less than or equal to. Now, guys, really quick. From now on, when I'm asking you for the domain and the range, pay attention to this. These are never going to change. Everybody look up. This one, and this one, and this one, and this one will never change. The direction never changes. Tell your neighbor what I just said. What we do need to worry about if it's equal to. We need to look at the graph. Let's look at this graph. Oh, sorry. By looking at the graph, does it include the point? Does it include a point here? And you're saying, well, how do we know if it doesn't include it? They will do something like this. Watch. Is that an open circle? Yes. When they have an open circle, does it include the 5 here? No, so then it wouldn't have the equal sign. How about here? Would it include the 3? No, it wouldn't have the equal sign. Does everybody understand? So therefore, that's the only thing we need to worry about. So therefore, copy that, please. If you already did it, that's fine. If not, make a note for yourself. Here, use the pencil test to find range. Range. Okay, so underneath that, let's do one more and label this one example. What example are we on? 4. Okay, example Q. Okay, copy that, please. So you get a real number line for our x value, and we got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. For the y value, let's do 1, 2, 3, 4, 5, 6, and I'll stop right there. 1, 2, 3, 4, 5, 6. 7 of x, 6 of y. Okay? And let's place a graph there. Let me see. I'm going to do that in green. And let's see. No, I'm going to place it, let's see, right here, going in this direction. Right there. Okay? So, find me the domain and range. Domain and range of that graph, please. Go. Okay, so let's see. I'm going to write my domain first. Domain. the domain, I see that it starts at 2 and it ends at 7. So I write 2, 7. And what variable are we looking at? X for the domain. And what did I say that never changes? The arrows. Those never change. What we do need to worry about, does it include the 2? Yes. So therefore I write a equal sign underneath. Does it include the 7? Yes. Okay, I got my domain. Range. I use my pencil test. And my pencil is a blue pencil. Let's see. I'm going to scan it from the bottom to the top. Where does it start? Right there. What number of Y is it? 1. Here it is. It's 1. And if I continue scanning, where does it end? 6. So my range is from 1 to 6, and it's the Y value, and the arrows never change. Is that correct? So let's see. Does it include 1? Does it include 1? Yes, because it's a close point. Does it include 6? Yes, it's a close point. And that's how we got our domain and range. Hands if you got that by yourself. Okay? Not bad? All right. So we're done with that. And for homework, check this out. For homework, I gave you something like this. Pens down. You don't need to copy this. I just want to double check that we got this. And we know that this is our X value, and the one on the right is our Y value. So we said that the domain is all X values. Is that correct? So my domain for this mapping diagram is 6, 5, 2, 1. So far, so good? And our range is -4, -1, and 0. Okay? No, I said don't write it down. You did this for homework, right? And then I gave you something like this also. Look at this one. I gave you guys a table like this. And they ask you, what is a domain? And of course, we know all X values. So the domain for this one is 1, 4, 8. The range for this one is 1, 4. And why didn't we write the 1 again? Because it already is written here. That's why we don't write it twice. Okay? All right. So with that said, we're done with relations. We're going to continue with relations, but now I'm going to give you a quick intro to functions. Yay. Here we go. Functions. All right. Pens down, eyes up here. Now, for this one, I'm going to bring back my vending machine. Here it is. All right. So my vending machine, you know, I'm going to send out people to go get sodas, and I need to keep track of my inventory to see what is being sold. So therefore, I'm going to go ahead and make a table to keep track of it. And I said this is X, this is Y, and we have so many buttons. We have button number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 23. All right. So first drink, yes. Okay, so they press 3 and they get a Diet Pepsi. Okay. All right, yes. So then they press number 10 and they get a Dr. Pepper. Okay, yes. What? A what? No, it's not. No Snapple. Sorry. Yes, right here. Then they press 2 and they get a Diet Coke. Yes? Water. And then they press 5 and they get a water. Okay? So then the next person's coming up. Yeah? And they want a Coke, so they press 1 and they get a Coke. So now check this out. I send someone else and they go and they press 1, but nothing comes out, and then here it says no more of the product available. So which one do we press? 7, and we get a Coke. Okay, so far so good, right? So then that person comes back, and they come in, and then who likes Coke from here? Okay, so then they go, Jay, if you're gonna go get a soda, yeah, I'm next. Yeah, so just press number 7. So Jay goes over, he presses number 7, and all of a sudden he gets a T. so who's has that happened to you sometimes? Yes. Yeah? Okay, now check this out. So let me ask you this. So far up to right here, it's been working well so far, right? What happened here? Is this machine functioning correctly up to right here? No. Guys, is it as soon as you see this happen right here, is it functioning correctly? No. Well, guess what? With relations, all these points, remember they're ordered pairs. Who sees the ordered pairs? Yeah, right here, right? Here, 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 here. The collection of all these, it's a relation. Are we there? In order for this to be a function, according to our definition, for every one input, there's exactly one output. Now, check this out. I'm going to point this out. Who sees that for this input of 7, there's 2 different outputs? You guys see that? Yeah, right? So therefore, this relation is not a function. Why not a function? Because this machine is not functioning well. Everybody with me? Okay, so you're going to copy this table down, please, and you're going to write if the X value repeats and has what? 2 different outputs, then it's not a function. Copy that, please. All right, copy this next example down, please. Only copy the relation, please. The relation. Here we go. Example 4. And don't mind this. Example 4. Copy this relation down, please. 3, -2, 5, -1, 4, 0, 3, 1. Copy that down, please. And as you're finishing up, I want you to make a table. Make a table on the side. All right. And right away, I'm going to identify all my X values. And all my Y values. Okay. So let's see. I'm going to place my first ordered pair on my table. What is my ordered pair? 3, -2. What's my second one? 5, -1. My next one, 4, 0. My next one, 3, 1. Okay. So now, they're saying, give the domain and range. What is the domain for this one? 3, 5, 7. I'm sorry, 3, 5, 4. Do we repeat the 3?
No.
No. So therefore the domain, focus please, the domain is 3, 5, and 4. Okay? And what is our range? -2, -1, 0, and 1. Okay? So now check this out. They're asking, tell whether the relation is a function. Let's see. What are we going to check? To see if a number for X repeats. Does a number from X repeat? Yes, the 3. So now, if it repeats from here to here, it should have the same Y value. Does it have the same Y value? No. Therefore, it has 2 different outputs, so this is not a function. It's only a relation, not a function. only relation. If they ask you to explain, what would you say? It's only a relation because it has two different values for one of the numbers of the x. Okay? Okay, let's go to the next one. Copy this next one, please. Copy this. This is the x column. This is the y column. And we have -4, -8, 4, and 5. So I'm going to write my domain right away. My domain is -4, -8, 4, and 5. My range is what? 2, 1. Blessing. Blessing. So now let's see. They're asking, is it a relation only or is it a function? So let's see. Here's -4, has one output. -8 has one output. 4 has one output. And 5 has one output. Is this a function?
Yes.
Yes, this is function. Yes. Why? Because there's, for every one input, there's exactly one output. Now, some of you are still not clear. Check this out. To clarify it. If I was to do this, and I placed another number here, and the -4 or any of these also had an arrow going to that, do you see how now that -4 has two different numbers? That's why it's not a function, when it has two different outputs. Everybody with me? Okay. Hold on, we're almost done. Almost done. Last one. Check this out. Don't copy this, just pay attention. This is exactly the same as the first graph that I gave you. Pay attention, please. To get the domain. Check this out. I start at my x values. Where does the graph start? Let's see. 1, 2, 3, 4, at -5. Who sees that it starts at -5? Okay. And where does it end? At 3. So my domain is from -5 to 3. X. We know that the arrows are the same. Does it include this point? Yes. Does it include that point? Yes. The range, you know how to get the range. However, check this out. They're asking, tell whether the relation is a function. So let's see. You need to get your pencil. You're going to scan this from left to right. Pay attention on this one. Let's scan this from left to right. As soon as the pencil touches two different values for x, do you see how the pencil touches here and here? Does everybody see that it touches here and here? Yes? Therefore, this is not a function. That's what we call the vertical line test. So homework. What is the homework, guys?
1 to 2, 11 to 14.
2, 10. What is 1 to 2? 11 through 14. 17 to 24 and 35. Have a good one, guys. Enjoy your homework. I'll see you guys tomorrow.